Today we're going to cover topic 1.6, and we've been doing a lot of things with limits just conceptually. But now we're going to get back to where we need to look at some things with limits algebraically. All right? And we're going to start with a couple simple warm-up problems here. We've said that if we have plain old functions that we know a lot about, that if I want to find the limit as x approaches 5, then I can just plug the 5 in and find the answer. We call that substitution. All right? This is what I would call the substitution method. Because this is just a plain old linear. We know a lot about this linear. This linear goes through 2, and it's pretty steep, all right? And we know that if I approach 5, the function is going to approach 27. Pretty easy. And we also know a lot about this function on number 2. We know that it's just a regular old square root function, all right? And so we can plug this in. We can just substitute again. 10 times 3 minus 5. So that's the square root of 25. This is 5. Okay? So this square root function, as we approach 3, is going to approach 5. All right? However that function looks, it's probably going to start somewhere, shift it a little bit, and kind of, go up this way, whatever. All right? So we could check that on the graphing calculator to see exactly the shape, but the idea is that it approaches 5. So that brings me to this plan that is always helpful to my calculus students. When it comes to finding limits, you always want to try substitution first. All right, always try to just plug in the number first, see if that works. What's going to happen is sometimes it's going to give you a screwy answer, like it's undefined or something. If that doesn't work, then you go to the second plan of attack, which is to manipulate or factor algebraically, right? And I know none of you ever want to manipulate, to like get something you want at home. Where do you want to go out to eat tonight? I don't care. And so then, mom or dad says, well, how about Olive Garden? I guess. So then you say that. That might be translated as manipulation. I don't know, but you just want to be cautious about that. But in this case, it helps us. In this case, manipulating helps us. And then step 3 is if 1 and 2 don't work, then sometimes we just got to look at the graph and find the answer. All right? So let's look at this example. This is actually the third example that we're doing here. If I try to substitute this right now, if I try to go ahead and plug in 3, look what happens. I'm going to have 9 plus 4 times 3, which is 12, minus 21, all over 9 minus 9, which is a big mess. It's 0 over 0. We actually call that, you're going to learn, an indeterminate form. Indeterminate form, of course, you recognize that 0 in the bottom as being a problem. All right? But we see this, step 1 of substituting did not work. So let's go to step 2, which is doing some algebraic factoring or manipulating. All right? So let's take this thing and let's factor it. The top will factor into x plus 7 times x minus 3. And does everybody see that if I take a negative out of this bottom, if I take a negative out, it becomes x squared minus 9? You all see that? You see that why that would be handy, don't you? Because that, if I take that negative out now, now I just have that this factors into x plus 3 times x minus 3. Right? It's a nice little trick that I showed you last year. You may have forgotten. And so now these two binomials go away. And now, like I said on this last page, now we reevaluate. All right, so now let's do the limit as x approaches 3 of x plus 7 over the negative of x plus 3, like that. And let's see if it works this time. Now let's substitute. All right, now let's substitute. And so I get 3 plus 7 over the negative of 3 plus 3. And we're okay. We get 10 over negative 6, which is negative 5/3. All right, and it works out that way. So we tried the first plan, which was substituting. It did not work out so well. You could put a little frowny face up here. And so then we went to algebraic manipulation. And it works. And that's what you're going to be doing a lot of the next couple days. All right? So, once again, if you try plugging in 2 here, if I try to plug in 2, I think you can see we've got a problem, don't we? I've got a 0 in the denominator. So let's do some factoring. On the top, I can pull out an x squared, which leaves me with x minus 2. On the bottom, I can pull out a 3, which leaves me with an x minus 2. The x minus 2's factor out. And now I can reevaluate the limit as x approaches 2 of just regular old x squared over 3. And now I can plug the 2 in, and I have 2 squared over 3, which is 4/3. Okay? Good old-fashioned algebra skills will come in handy in this case. Oh, this is a repeat problem. We've already done this one. Let's keep going. So this problem, we have a similar problem. If I put in a negative 8 right here, you see that we've got a problem. We've got a 0 in the denominator. That ain't going to work. So this requires a little bit different ticket of manipulation because there's no factoring really that I can do. But I did show you something, a little trick back in pre-calculus, that I could multiply the top and bottom here by x plus 6. That is totally acceptable because it's a form of 1. X plus 6 over x plus 6 is 1. All right, so I'm not changing the expression any, I'm just manipulating it. Again, this is a good case of manipulation. Now, when I distribute this to both of these, then the x plus 6's cancel right here. All right? And I just have x minus 4 times the x plus 6. On the bottom, I have x plus 8 times x plus 6. And now we can work on re-evaluating the limit. All right? Now, the x plus 6's are going to go away. No, not yet. Sorry. Let's keep going here. Let's simplify this thing some more. We have x minus 4x minus 24 all over x plus 8 times x plus 6. All right. And on top, I now have negative 3x minus 24. And I'll tell you what I'm looking for. I'm looking for a way to get rid of that x plus 8 in the bottom. Because the x plus 8 is the problem. And do you see that it's going to go away? if I change this to negative 3, if I pull out a negative 3, don't I have an x plus 8 there? And yay for us, we have gotten rid of the x plus 8 that is the problem. All right? And so now I just get to evaluate, I'm going to come up here where I have space, the limit as x approaches negative 8 of negative 3 over x plus 6. Now you can plug in your negative 8. You have negative 3 over negative 2, which is the answer we were looking for, 3/2. So again, notice you do not want to plug in here. Do not plug in here. You need to clean this thing up a little bit like we did so you can get rid of that x plus 8, which was the problem. All right? All right, one more little algebraic manipulation trick that you may have forgotten about. If I plug in 5 here, I get a 0 in the denominator. Problem, so we need to do some algebraic manipulation, which you may or may not have forgotten about using the conjugate. I can multiply the top by the square root of x and the bottom by square root of x plus 4 plus 3 over the square root of x plus 4 plus 3. Once again, we're trying to get rid of that x minus 5 in the bottom. All right? So look what happens on top. On top, I have a difference of 2 squares. So that becomes x plus 4 minus 9. The square root of x plus 4 times the square root of x plus 4 is just x plus 4. And I have a difference of 2 squares all over x minus 5 times the square root of x plus 4 plus 3. Now I think you can see, yay for us, that's x minus 5. And so we can, now we can cancel out the x minus 5s. We got rid of the problem. And so now I can reevaluate the limit as x approaches 5 of 1 over the square root of x plus 4 plus 3. So that, now I can substitute. I have 1 over, that's going to be the square root of 9 plus 3, which is 1/6. And yay for us, we did a good job on that problem. And we will stop there for today.